Okay, guys, for this quiz, I'm recapping for the sake of this video here when you go back to watch it. The task is to create the waffle frame, then create the sunshade extrusions, and they are to actually be exactly fit to the inside of the frame. That's really the only parameters outside of the fact that I want it on a 20 by 20 surface. So I already kind of previewed this for you. That let me turn off the sample again. That all I did was create a curve in Rhino, and I tilted it off of the XY axis to make sure that it's not, to make sure that you can't use unit X, Y, or Z. So all you need to do here is divide this thing up into your frame subdivisions, however many they are, and I don't really care how many they are. The key to that is these two things. The construct domain squared and reparametrizing. But I didn't give you the other part of reparametrize. The other part of reparametrize is that it has to happen on the isotrim command. Remember that? That holy trinity, right? Isotrim and the surface and the domain. So this doesn't happen till later, though I gave that to you up front because it's new. But this happens now. All you need to do is create your subdivisions, but the first part before you do this is to actually do your subdivisions, right? So you're gonna have like a two-step isotrim function here. First is subdivision, then it's size reduction, because this one right here is to reduce the size of the domain, not subdivide it. That's why I gave you that one, because it's newer. So the first thing you're going to do is under math domain and divide domain squared. So that may have confused you because it's sort of two different domain functions that you need to pair up together. So first off, we need surface utility isotrim, and this is that holy trinity of these components here, right? It's surface, and then the actual surface subdivision function. Then it's the divide function gets plugged in there, and the surface function gets plugged in here. That's a triangle, those three. It almost always happens that way. So then you're going to need your sliders for number of subdivisions, and those sliders go from 0 to 10. There's your number of subdivisions. So what happens next? What?
Do you reduce it?
Yeah, the next step is to reduce it. And to reduce it, that's where I need my reparametrize setting. That happens on the subsurface setting. So all I need to do is copy and paste this thing over, go from surface to surface now, and plug this domain in there, and that one is going to be reparametrized. Okay, so going back to our subdivisions and our domain reductions, these sliders are quite different. Remember on Thursday we talked about these sliders in the sense that they're actually either percentage values or orders of magnitude. So with reparametrize, we've established it to be a percentage reduction. So we're going to make sliders from 0 to 1.00. All four of them. Okay, and if you really want to do, I mean, I'm doing this a little bit more difficult than it has to be. Technically, you could just scale something 5%, but that doesn't work in three-dimensional applications. That's why I did this. So if you're scaling it 5% from all sides, you actually need to put in a 5% value from each of these. But remember, the U max and the V max are actually supposed to default to 1.0. That gives you your full panel, right? U minimum 0, U maximum is 1. And then your reduction happens from that boundary. So 0 is a 0.05 to go 5% away from that side. 1 would be a 0.95, and then repeat that here. So when this gets turned off, what you see is that. Now, remember, this is a little bit more simplified, and it's also kind of the inverse of what you actually need, because this surface right now is still solid. So that's your hint for now. I'm going to leave you with this to figure out how to actually create that waffle frame. Yes?
I'm stuck on the surface. Me too.
I'll come check it out. All right. So after this, yeah, sorry. Let me turn this stuff off again. After this, what you'll want to do is make sure that you subtract this information. Okay, so that's really just, I take my original surfaces and my cut surfaces like that, and that becomes a subtraction. It's that simple.
What?
All you do is put your original surfaces, the full size ones, in the A input. Then you take the subtracting surfaces and you put them in the B input. So the next hardest thing, and after this, everything is so easy. So I'm going to give you one more little hint segment, and then you can figure it out from there. Okay? The hardest part after this is finding the vector, right? And there are a few ways that you can do it. I like to use the surface analysis tools, right? That there are a couple of like really wild ones that I wired together because it's a little bit more predictable and easy to manage. But it is a little bit confusing to a new user. So here's what you do. The key is I'm going to find the surface off of the original surface, right? This one right here, because I want the frame to extrude in that direction. Like I exactly want the frame to move in the direction of the whole surface because this is a planar system. Only because it's a planar system. When we get into warped systems with extrusions, it's a whole new ballgame. We'll talk about that later. But there are three elements you're going to want. It's under surface analysis, you're going to want area. And then you're also going to want evaluate surface and surface closest point. So I'll quickly go over that again. That's area, evaluate surface, and surface closest point. And they're going to look a little wild, but they're going to string together like this. They're going to actually come off of the original surface. So let me just put a param on that looks kind of like this. Get it out of the way. Okay, you guys follow that? I just added another param so it moves it down here. So it's going to be surface into area. And then you can just plug your surface into the S input of the other two. That's not a big deal. Then you're going to go, your centroid is going to plug into surface closest point. And then the UVP output is going to plug into UV of evaluate surface. This, you need to remember. So what does that do? That gets you a vector for you to use. Making sense?
No.
Yeah.
How do you get the surface CP?
Once again, they're all, guys, I need all of you to pay attention. the three that you want for this part of the definition is area, that finds the centroid of the surface. Then evaluate surface and surface closest point. So write that one down in your notes when you get a chance, because we're going to use that a lot. All right, yeah. Yeah, that's the main surface. I just created a double param so that it would just feed the information down. Yes? This is valid for planar surfaces, yes. When it gets three-dimensional, it's going to be closer to what you were trying to do. So this is actually, believe it or not, this is the simplified version. Because what happens is what this is doing, guys, is it's creating one. Let me turn some stuff off. Let's turn that on, and then this on. So all this is creating is one extrusion vector, and it maps to the original plane. What happens is when you get into a warped surface, you actually have to track all four corners of these points, and then you have to calculate their vector from four other vectors to find where the new extruded point is going to be. Or you can do it with offset surfaces and stuff. There are a couple of cheat ways to shortcut that, but yeah. So it gets far more complicated to do it that way. But when it's planar, it's super easy. All right. So other questions before I give you another? Is 15 minutes, you think, going to be enough? All you need to do is extrude it at this point, and then, you know, do another domain and make the awning and then extrude that. That's all. Yes? Yes.